Okay, so thanks for coming to my talk, Building Apps Across Platforms with Flutter. You'll notice this slide is a little different than building apps across platforms with Flutter. It's called Adaptable Apps with Flutter. So I pitched this talk and it got accepted, and I started doing more and more research into this. And I realized that building apps across platforms is great, and Flutter helps you with that. And we'll talk a little bit about that here. But the docs for Flutter actually tell you how to do it, and it's really easy. So I wanted to take it up a notch and talk about building adaptable apps across platforms with Flutter. And I think that's going to be more useful. We'll still talk about Flutter. We'll dive into all of the fun stuff. That's the Flutter logo on the left. This thing right here. I'm Brad Cypert. I'm a staff software engineer at Team Snap. We're a remote company that does sports team management. I also run my own business where I make Flutter apps and write services in Golang and Rust and all sorts of fun stuff that using less popular technologies that I find really enjoyable. Today, we'll talk about one of those Flutter apps. So this quote kind of encompasses everything that we'll be talking about today, and I really like this quote. It's what separates design from art is that design is meant to be functional. It's by Cameron Moll. So this poses the question of like, what is functional design? You might think it's responsive design. Responsive design really kind of swept the industry about 10 years ago, maybe. Yeah, I'd say about 10. And it's a design approach that makes content render well on a variety of devices or screen sizes. You're probably familiar with it. Tables that shrink on phones, maybe they lose, or tables that scale up and maybe add columns on desktop is a really good example of that. Making sure images don't bleed. Generally, a well-done responsive design means that there's no horizontal scroll bar. Anytime you have a horizontal scroll bar, it's a good sign that maybe that design is not as responsive as it could be. But is responsive design functional? I would take it a step farther and say that adaptive design is where we start to get into functional design. So adaptive design is a design approach that fundamentally changes the way that content is accessed in order to best cater towards the user's expectations of how content on their devices should be accessed. I will try not to read directly from slides anymore, but I do want to just stress two key points from this one. So there are two things that are really important. First is it fundamentally changes the way that content is accessed. And then the second is best cater towards the user's expectations of how content on their device should be accessed. Think about that for a second. Okay, now that that's had time to settle in, let's move on. From the Flutter docs, they talk a little bit about adaptive design. And I think since we're talking about Flutter, it makes sense to talk about that. Mainly, they give you some tips, how to adapt an app to run on different device types. Handling mouse and keyboard input is a big one. You don't have those on your phones usually, but you do on a desktop or a laptop, maybe even a tablet. Handling apps visual density, so how dense the pixels are, how component selection works, platform-specific features, stuff like that. So this poses a really important question. What is Flutter? If you're in this talk, you probably have maybe heard of it, but probably not used it. So Flutter is Google's UI toolkit for building beautiful natively compiled applications. That's their tagline. The important part that I really want to stress here is the mobile, web, desktop, and embedded devices from a single code base. And I cannot stress enough that it was built for mobile. You can now do web. Web's a little flaky, unfortunately, but it's getting progressively better about every week. Desktop actually is pretty good, way better than I thought it would be because they've been working on web for a while. Desktop just came out, and it works pretty well. And embedded devices. So your refrigerator might run a Flutter app. I'm pretty sure the BMW cars run, like the BMW screens and cars run a Flutter app. Android Auto is built on Flutter. Kind of neat. There are some key things to take away, mainly that it's not responsive or adaptive, but it does provide the tools to make responsive or adaptive apps. It's also powered by Dart, which maybe leads us to another question of what the heck is Dart? So Dart's a general purpose programming language. I put general purpose in air quotes because it wasn't intended to be completely general purpose. It was originally optimized for client development. So clients being web, iOS, Android, any person who is maybe not running a server, but is connecting to servers or doing like providing user interfaces in particular. And Dart supports both of those features really well. It compiles to ARM, x64, JavaScript, mobile, web, desktop, kind of whatever you want. This is fairly common out of newer languages like Golang and Rust come to mind. One thing that it does that those two don't do very well is it has hot reloading, which is great for all of our JavaScript and TypeScript devs. We're pretty used to that at this point, so it's nice to keep that around. It has this concept of isolate-based concurrency. Isolates are like way out of the scope of this talk. They're really interesting, but it's an abstraction over their concurrency mechanism to allow you to treat concurrency the same regardless of the underlying platform it runs on. So you might be able to say, well, for example, if we compile it to ARM, that could mean a lot of different things. It could mean like an M1 MacBook, which has pretty solid support for concurrency. But it could also mean like an Arduino or a Raspberry Pi or something significantly smaller that maybe doesn't have as many threads to work with. Excuse me. Or maybe it's JavaScript, and in which case you have a single threaded runtime. So isolate-based concurrency gives you an abstraction over all of that. Very recently, they introduced sound null safety. This means that if your component supports your application supports sound null safety, it can guarantee whether it's null safe or not. The compiler will check that for you and say, hey, you're using something that could be null and shouldn't be, or could be null and you need to check for that. And then one thing I really like, most modern languages are doing this. I say modern, maybe next-gen languages, the ones that are coming out within the past 5 or 10 years. But it ships with tools for profiling, logging, debugging, formatting, things like that. Dart's familiar. So my code examples, there's a couple of them. I'll try to keep them somewhat short. I really like this one. This is actually from the Dart language homepage. But it shows you how similar Dart is to the things you might already know, especially if you're building clients already. So you can see that we have a class called segment. It has a property called links. It's set to 4. There's a toString method that does some string interpolation to say I have 4 links. You can see the same thing here in Kotlin. Actually, it looks really similar. You can see the same thing down here in TypeScript. Also looks pretty similar, a little more verbose. You could argue that this TypeScript doesn't have to be that verbose. They could drop some of the types there. And let it infer it. And then you have Swift. Swift always looks very different than anything else to me, but you can still see that there's quite a bit of similarity between Dart and Swift in this case. So here's some more code. I'll walk through it really quick and just point out some high levels. So we have package imports. You can think of these like node modules, jars, whatever, external dependencies that you're pulling into your application. You can have local imports. So we're importing a repo here. You have classes. So we have a class called pet repo. It extends this adaptable repo. There's inheritance. You can see that there's generics, something that Golang doesn't have, but Dart does. Sorry, I like to pick on Go. And then there are some patterns that are in place. Like, for example, generally when building client apps, it's fairly common to have singleton instances. So you can see this library uses that pattern to create like an instance whenever you pull it in. You have finals, you have not necessarily latent inits, but things that start null and are initialized by the constructor. This is your constructor. This is kind of neat. You have these curly braces around this property. This means that it's a named parameter. We'll see some examples of how to use name parameters in a bit, but it's something really unique to Dart, and I actually think that it works really well for building client-side applications. Additionally, provider is not a Dart specific thing or a Flutter specific thing. It's a library for dependency injection. So we do have tools for that. And then built into the standard library of Dart, you have streams and features. Streams are really neat. If you've done any reactive programming, you've probably worked with streams. One thing I really like about Dart is that there's support for converting futures to streams or promises to streams. And streams to promises and vice versa. You can actually see a really good example of that down here. Collection.doc.get returns a future, but we're converting it to a stream to conform to the interface required by this adaptable repo. So one thing I really like about Dart is that the syntax is very conducive to building widget or component trees. And we'll see an example of that here on the next one. If you're not familiar with what a widget or component tree is, it is a nested structure like HTML well, it's a tree. So it's a nested structure that like I'm sorry, trying to think of a great way to put it. Symbolizes your application structure. So just a couple of really cool things that I found while digging for, I guess, more research on this talk too as well. So this is a little dated. This is 2018 to 2019, but change in programming language use from the Stack Overflow survey. Dart was #1. That's pretty sweet. 532% gain. A lot of that was that a lot of people weren't using Dart, and then a fair number of people started to use Dart. You can see some other really great languages on here like Rust, HCL, some that I'm a little more concerned about like PowerShell. But yeah, Dart had like massive growth that year. Also pretty neat, for most popular technologies, if you're looking at the top of this, you're looking in the wrong spot. Dart is not at the top by any means, but it did make the board, and it made the board above Elixir, which is something we use at work all the time. It is under Scala. It made the board above Clojure, WebAssembly. So I don't know. I see some Clojure jobs. I see some Elixir job postings every now and then. So, you know, maybe Dart job postings are on the horizon too. So this one's really cool too. This was from the same survey, the most loved, dreaded, and wanted languages, specifically the loved tab. So Dart's highlighted here. It's right under JavaScript, which I think is pretty good. There's some people that seem to really like JavaScript, so being right under that feels pretty great. It's also quite a bit higher than like a lot of languages that are pretty popular. For example, Java, C++, Scala, a little less popular. Ruby, that's pretty popular. PHP, very popular. So that's kind of neat to see that people that like Dart actually, or the people that use Dart seem to really like it. My favorite part is Dart's claim to fame. So in 2013, Google said, hey, we're going to build the Dart VM into Chrome. This means you don't have to write JavaScript anymore. You can write applications on the web in Dart, and we'll let you compile it out to JavaScript. So on browsers that don't support the Dart VM, you can load the JavaScript fallback. And basically, we'll build a standard around how you load Dart apps, but also fall back to the JavaScript app if Dart's not available. And in 2015, Google said, actually, yeah, we're not going to do that. This has been a nightmare. There's a link to the article if you want to learn more, the TechCrunch article about Google saying we're not going to do what we said we would. Kind of somewhat common practice at this point. So maybe it's not as shocking as it was for me in 2015. But yeah, so this is important because this is the year that I stopped caring about Dart. I was really excited for it for about 2 years. And then I said, okay, you know what? I'm never going to use it again. And then I was introduced to Flutter. So Flutter uses Dart, like we've mentioned. This is some Dart code. And I really want to stress the component and widget tree nature of this. You don't have to read the code. There's actually a lot going on here. We're not going to look into any of the specific pieces, but I just want to highlight that there is this curve of indentation. This could mean multiple things. This could mean that you have very high cyclomatic complexity and you should break things up into smaller functions. In this case, I don't think that's necessarily the case, but I think it highlights that there is a tree structure here. It's safe to say that if you've written much HTML, as your indentation starts to get bigger, you have a bigger HTML tree. And you can see the same thing here with Dart. What's really cool about that, what we just showed, is that's not exactly just Dart code. It's also Flutter code. So this poses another question of how does Flutter work? So there are three main pieces. So you have the framework, which is what you as an app developer will spend most of your time working with. This includes a standard set of widgets that have no display associated with them. So for example, the padding widget doesn't have any like implicit display. It just puts space around whatever child widget is passed to it. You have material widgets, which give you a material look and feel. You have Cupertino widgets, which give you the Apple human interface guidelines style-ish widgets. You have tools for rendering, you have tools for animation, painting, gestures, foundation. The foundation is going to be everything that kind of brings it together and bridges the gap to the engine. Most of the time, you won't do much with the engine unless you're doing some much lower level work. For example, maybe building a game that runs on the Flutter platform. You might have to hook into some of this. And there are libraries for building games in Flutter. So you have things like, we'll just touch on a couple of them. So you'll notice rendering here as well. This is a lower level interface into how things are rendered. Isolates, hey, they make an appearance here as well. So like how to set up isolates, frame scheduling, so making sure that you're rendering frames in the right order and ideally at 60 frames per second or 30 frames per second, whatever you feel you need. Asset resolution is another one, like how do we load images from the file system? Those are all pretty relevant. And then you have the embedder, which is going to be your platform specific stuff. So the embedder is going to say, if I'm running on JavaScript, give me these things. If I'm running on x64, give me these things. And that's going to, the biggest thing there probably is your native plugins. So being able to interop with like native Swift code or Objective-C or Kotlin or Java or JavaScript, depending on your platform that you're targeting. Like how do you interact with those? Event loop interop. So if you are working on JavaScript, how do you get that interop? That kind of makes things work. And then thread setup as well. So if you're using something that supports multi-threading, making sure that that is set up properly. So this is a Flutter app. This is it. Thanks for coming to my talk. Just kidding. Sorry. I need like a laugh track because I'm sure that everyone's laughing about that. That was also sarcasm. But so you have a void method. It's called main. This is fairly standard for most applications. In any language, you have a main method, and it usually is void. You can optionally make it async. In our case, this one's async. Actually, it probably doesn't need to be, but I really wanted to stress that you can make it async. And then you pull in an import from Flutter called run app, and then you pass it your app, and that's how you run your Flutter app. So what does my app look like? So my app is a class. It uses inheritance to extend a stateless widget. So there are two types of widgets. They're stateless and stateful. That means exactly what you think it would. Stateless widgets don't have state. Stateful widgets can have state and can be triggered to re-render when that state is updated. And then both stateless and stateful have a lifecycle method that you override called build. This returns a widget. It takes in a build context. So this context is information about where this widget is being rendered. And then you can return whatever you want. In this case, we're returning a multi-provider. This is from the provider package that I mentioned earlier. It's not a part of Dart or Flutter. It's an external package, but it sets up dependency injection. And then you pass it a child. And this is a pretty common practice. Widgets take children or childs, and there is a difference between the two. And that's what gets rendered inside of that widget. And in our case, we're passing it main app content. So what does main app content look like? It's also a stateless widget. We can do quite a bit in our build, as you can see here. We're actually pulling a theme service out of our dependency injection that we just set up on the previous slide. We're returning a material app. So this app uses the material look and feel. We're giving it a title. In this case, it's just a string. Excuse me. There's a theme. This is kind of neat. This is like 50% of the code you need to allow users to select their theme through your application. So just pulling it out of the dependency injection tree and then saying something like, hey, get theme data for the active theme, which is pretty cool. There's this weird little flag called debug show checked mode banner. It's this little banner that shows up in the top right corner that says debug. I guess it's great if you are doing debug builds and you don't want people to think, wow, this is production. Or maybe you're handing things to QA to make sure that like they know it's a debug build. It is really kind of strange. And then there's support for routing, specifically for deep links and routing on the web. So keep in mind that this is both iOS, Android, I say both, sorry, all iOS, Android, web, desktop, etc. So what's really neat is if you're doing something like desktop, you actually can still use routing and still treat things like routes, even though there's not really like a routing mechanism in place for desktop applications like there are web and native mobile, sorry. So this is what a build method for like an actual component looks like that shows something on the screen. Everything we've seen so far has been like setup, dependency injection, and setting up like a, not necessarily a scaffold, because you'll see that we're actually doing a visual scaffold in this one, but the things necessary to actually start rendering things on the screen. So in this one, it's another build method. We have a scaffold. So the scaffold is a material widget, and what it does is it gives you access to set up an app bar, which is the bar at the top of most material apps that hopefully everyone's somewhat familiar with. and then also whether you have a drawer or not, and then the body, so the stuff that goes inside of that app bar and drawer combo. So one thing I really like about Dart and Flutter in particular is actually this. So you can see here we have we set up our app bar. It has a title. It's a text widget. Okay, nothing fancy. Actions is an array. We are conditionally adding an item to this array. So if we're in edit mode, then this array has a container inside of it. If we're not in edit mode, this array has a container inside of it. If we're in edit mode, there is no actions is just an empty list. And this is really nice when you start to actually build large scale applications and you're not having to, you can inline like your conditional displays. It makes it very declarative. You're not like shoving things into an array at the top of the build method and then saying actions is equal to actions, which I defined 20 lines above. And then finally, you can see down here, we're setting the drawer to null. In this case, we don't want to show a drawer. I think in the case of this application, it's because we are already like a layer deep and we want to show a back arrow instead. So since the drawer is set to null, it'll show a back arrow. And then body, we check to see if you're in edit mode. If you are, we render an edit form. Otherwise, we render the view container. Edit form and view container are widgets as well that we've defined. So you put some widgets in a tree. And before we go any farther, I really want to stress that I am not a designer. I have done client and interface development for 11 years, so I have some ideas of what works well and what things kind of fit together. But in terms of making things look pretty, I am generally not that person. However, you put all those widgets in a tree and you get something like this. And I actually think this looks pretty darn good for a non-designer. I'm sure some designer in the audience could probably say, oh, this is all wrong and should do this instead. And if you want to do that for me, let me know because I'd be happy to make those changes. But this looks pretty good, right? So we have our app bar up here. We have our drawer. We have some widgets. This is a big widget comprised of smaller widgets like an image and a dropdown and a text. And we have another widget for like our grid and then some items in that grid. Pretty good. So you get really excited about this, right? You download it on your phone. You show your best friend. Your best friend downloads it. You show your parents download it. And everyone's like, wow, this is really cool. I can't believe you made this. This is so awesome. And then your parents tell your grandparents and your grandparents call you and they say, I can't see well on my phone. So I downloaded this on my tablet. And now it looks something like this. And whether you're a designer or not, I think it's safe to say that this looks pretty bad. So how do we make this better? You open up your Xcode project and say, I don't support iPad. Except you can't do that. There was once a point in time where you could. Apple is very stringent about that. And they want your iOS apps to work on iPad OS as well. Rightfully so. So we can identify some of the troublemakers here. I'll go back really quick so you can see the grid again. So there's some key things to think about. This grid's a 3x3 grid, 3x. It really scales indefinitely vertically, but you can see that there's 3 items per row, and that's part of our problem here. So I think we can identify that pretty quick. So we have our grid view count. We have some stuff about whether it's a primary grid, and this just handles which grid scrolls. Shrink wrap means don't take up more space than you absolutely need to. There's some padding. Cross-axis spacing, main axis spacing. Hey, look, 3. That seems like our troublemaker. So how do we handle that? We have a couple different options to make our app a little more responsive. We can introduce the media query. So the media query has a method called of. It's a factory method, a factory constructor, which is a Dart-specific constructor. There are actually quite a few constructors in Dart, which is a topic for another time. But you pass it a context and it gives you a media query. And there are some methods like size, the device pixel ratio, the orientation, text scale factor, view insets. This one, all of these are probably pretty obvious. View insets might not be. So this is information about the parts of the display that are obscured by system UI, like the keyboard. So if like a keyboard is up, or if maybe not necessarily like the Facebook Messenger bubbles on Android, because those aren't system UI, but if the system were to provide something like that, you would know that things are obscured by it. Okay, so we can change this, right? We can add a media query. So we can say media query of context. And then we check the width and we say, if it's bigger than 900 pixels, we're probably on a fairly large screen, or we for sure are on a fairly large screen. So make it 5 instead of 3. And you can see us implementing that right here. And the outcome is something like this. That's not bad. It gives us a lot of white space at the bottom, and that feels a little weird, but the icon spacing feels better. So let's see if we can do better. So if we continue down this path, we can identify 2 more culprits. Sorry, there's a lot of code here. You don't have to take it all in. I'll highlight the key parts, and we'll break them apart in the next couple of slides. So the first one is this icon button. You can see it's a troublemaker, mainly because the icon size is hard-coded to 36. And then text. You can see that the text size is hard-coded to 16. So our icon button, icon size 36. What can we do? We can do another media query. And this one's interesting because let's spice it up a bit and let's check the orientation. So if we're in portrait, we want to use the aspect ratio and we want to multiply it by a weight. So if we're in portrait, our weight will be 4. And then we'll multiply it by a root value. And if we're not in portrait, we're in landscape, we want to use the aspect ratio and multiply it by a weight and then a root value here as well. These numbers, while they did work and look fairly decent, I don't recommend copying these numbers into your application. Every application is going to be a little different based off the context that things are rendered in. But it does really stress the idea that you can multiply by a weight and then multiply by a root value using the aspect ratio. So here's some aspect ratio tips. Maybe that math didn't make a lot of sense. Let's talk about it. So phones are slimmer than tablets. So those are going to create a more extreme aspect ratio. For example, on a phone, you might have like a 1.8, but on a tablet, you might have like an 0.9 aspect ratio. In fact, some phones could be even more than 1.8. I think I saw one that was like 2.6. And that actually, in hindsight, thinking about that feels pretty low. I imagine it could go quite a bit higher. Aspect ratio changes with the orientation, though. It's width times height, or width over height. And if you change your orientation, the system recognizes the width as whatever the width is for that orientation. And the same with the height. So you can multiply by a weight to help help direct how much influence the aspect ratio actually has. We did that on the past screen. I mentioned that weight value. Anything like 0.5 to 2 is fairly common. So let's tackle the same thing with our text, right? So we have a font size of 16. We can do a media query here. I'm storing it in a variable called media data. I'm leveraging the text scale factor. So the text scale factor is nice. This is where it starts to feel adaptive. The text scale factor is on mobile devices in particular, you can set the text scale on your system settings to be higher. This is for people with impaired vision or people who just prefer to have larger text to read. I don't like to always wear my glasses, so sometimes my text is scaled up because it's easier for me to read without my glasses. And then you can see that we're doing the same thing here. We're using our media data, we're getting the aspect ratio, and we're using a method called clamp. This is new, but it's a method on a number, and we'll talk about it more in just a second. And then we're multiplying by that default value. So clamp is interesting because it's something built into Dart, not so much Flutter. And it's basic math, really. It's nothing crazy, but it clamps a number to a range. So if you have like a number 8 and you say the range is 0.8 and 1.2, it will do some math using compare to and give you a value within 0.8 and 1.2, which is really nice. So if you had maybe 6, for example, the value that you would get clamped is going to be less than the value you would get clamped with 8. So it's consistent. It's a great way to like force values into a specific range of numbers, but still allow you to scale differently depending on the initial value. So we'll talk a little bit more about a couple responsive widgets, and then we'll move on to adaptive stuff because we are already starting to make good headway on time. Cool. So there are tools like Flex that help with responsive widgets. If you're familiar with web development, the Flex suite of widgets is probably going to be really obvious. So flexible is probably the key one to know first. It indicates that the children can flex. So you can set a flexible area. Maybe it's a width of like 900 pixels. And then you can say, I'm going to put a flex and an expanded in there. And I'm going to have that flex be set to 1. And then I'm going to have the expanded be the other element. So the flex of 1 is saying, hey, it's going to take up, a small flexible amount of space. And then the expanded is a flex that is hard set to the maximum amount of remaining space. So if you flex a little bit and then have an expanded, the expanded is going to take up the rest of that space. So we've made our app a bit more responsive, but how do we make it more adaptive? We talked about functional design, and I think, mostly agreed that adaptive design is far more functional than responsive. So some things to keep in mind. With adaptive design, we adapt based off of the application, the platform that the application is running on. So tablets, laptops, desktops, they all have tighter or closer to 1 aspect ratios than phones, which means you have more space to work with. Watches also have a tighter aspect ratio than phones, but that means you actually have less space to work with. So you can't always depend on your aspect ratio. So think about how people are using the device that you're building for. Most people would prefer to perform heavy workloads on a desktop or laptop computer, myself included. I know several artists, multitaskers that love tablets. My manager uses a tablet for almost everything he does at work. I think, at least he was at one point in time. I'm not sure if he still is, but so tablets kind of have their own use cases. And then the last one, I hate typing on a phone. Please don't make me do it. Please allow me to type on a desktop if possible. So here's a really interesting example of how we can make something more adaptive. So this is the UI that you saw earlier on the left. This is what happens whenever I tap the dropdown. So you can see that there's multiple pets here. There's Luna, there's Test Pet, there's Shrimp, and then there's a button to manage the pets that you have on your account. So this is interesting. If this is so important, why is pet selection hidden behind a dropdown? It's critical enough that I kept it on the home screen. All of your actions start with a pet, so you want to be able to swap between pets fairly easily. But truth be told, I ran out of space. That's why it's hidden behind a dropdown. It needs to be on the home screen, and I didn't have space for it. However, on tablet, it's still critical enough to keep on the home screen, but I have plenty of space. So let's walk through what scaling this for tablet might look like. So we have a widget called Layout Builder. If you talk to Flutter developers and you ask them what their favorite widget is, I have a pretty strong feeling that most of them would recommend would say Layout Builder is their favorite widget. So it's, in my opinion, the cream of the crop for adaptive and responsive layouts. You use it for building large layouts, but you can also use it for deciding how small widgets should render. So you can not only just change layouts, but you can change the entire way that a widget should render based off of the constraints passed into the Layout Builder. There's 2 links here. I will share the slides in the chat once I'm finished. I meant to do that beforehand, but I totally forgot. And you can click any of these links if you'd like to learn more. But this video's Flutter does Widget of the Week, where they talk about popular widgets and help people use them. They're like 2 to 5 minute videos on YouTube. And then the Layout Builder docs are really good because Layout Builder is used a lot. So they took a lot of care into writing those docs. So we're going to build something like this. So we have a master detail view. This used to be really, really popular. I actually reckon that it still probably is. Your email apps, your text apps, things like that. If you were to open them on a tablet, I imagine they would do something like this. So it's a list on the left and the details on the right. So how do we do that? We can use the Layout Builder. So Layout Builder is an interesting widget. It actually takes in, instead of a child, it takes in a builder function. And that builder function has access to the context and the constraints that it's building in. So we can check those constraints. For example, constraints.maxWidth is greater than 900, then we return things in a row. Otherwise, we return them in a column. So if you're on a very large screen, sorry, we return things from we orient things left to right. If you're on a small screen, we orient things from top to bottom. And you can actually see here that for the most part, the children are fairly similar. You'll notice that these are flexibles, and these are, this is a hard set container, and the other's flexible. But the contents of those are the same. So we're using the same pet card here and here, regardless of whether you're orienting it from top to bottom or left to right. And truth be told, for what it's worth, top to bottom and left to right are very specific in this case. You can easily do right to left in Flutter, or if you need to, bottom to top if you really wanted to. And it's very easy to support those orientations for cultures that may expect that, while still supporting like your standard English US or orientations as well. So our grid will grow, right? So if we have more space, it will grow vertically, but we need to make changes to the pet selection too. So what we're going to do is we're going to completely change the way the component's rendered depending on the constraints. We'll check if the component's being rendered in a box greater than 400 pixels. If it is, then we will render a list view. If it's not, we'll continue to render that dropdown. So on phone, it's going to be smaller than 400 pixels. And if we're on a larger device, it'll be greater than 400 pixels. I have all the code for this in this link. It's really big. So if you want to look at all of the code and see how it all fits together for that widget, it's right there. Feel free in the future. We'll talk about the key parts right now, though. So we mentioned our constraints, right? So we said 400 pixels is what we wanted to work with. For what it's worth, these are density independent pixels. So if you've done much mobile development in the past, that probably means something to you. If not, you can think of them as similar to pixels, but it kind of depends on the pixel density of the device. And then, so we are checking the max height here. If it's greater than 400, we render things in a column, and you'll kind of see how that fits together in a moment. Otherwise, we render things in a row, and these are going to be drastically different. So that row is going to be an image. It's going to be what you saw on the phone earlier. It'll be the image of the dog, the drop down, and the birth date. Otherwise, we render things in a column, and that column is going to contain a list view. And it's going to look something like this. So you can see here that since we're on a tablet, a larger device, we're actually rendering things in a row, right? We go from left to right, and then we have our column that we just mentioned here. So with a few more changes, you can wire this up. These are all, like, the changes from this point forward are all logic specific. So for example, like whenever I tap on a dog here, it needs to activate the journal, the weight, the medications, the vaccinations for that dog, just like selecting one from the dropdown does on the phone. So that's pretty neat adaptive layout, but is it fully adaptive? Sorry, I guess it's important to say, is that fully adaptive? Is that app fully adaptive? No, there's so much more we could do. So we've done a lot with the UI. Let's think about how data is stored. With the project that I've been mentioning, by the way, it's called Luna Journal. I'll talk a little bit more about it at the end. But this was a big deal for multiple reasons. So we have a couple of options. The first option was cloud storage. Firebase is really easy to work with, so that's what we started with. But we saw a lot of value in persistent device storage, whether that was SQLite. There's a database, a NoSQL database for Flutter and Dart called Hive. And then also local storage. So like your shared preferences or literally local storage in the browser. We wanted to be able to support all of these. So how do you do that? So we're talking about adaptable apps. And there's no better design pattern than the adapter pattern. It kind of, the name implies it. So you can see here, back to Dart code, nothing Flutter specific here. We have this database adapter. And yet again, we're doing a package level import. We are doing an abstract class here. So we haven't talked about abstracts, but Dart does have abstract if you like to do things with abstract classes. Dart also, you'll notice the word trait here. If you're familiar with traits, Dart actually doesn't have traits. But through the way that abstract classes work in Dart, you can easily make your own implementation of traits, which I tend to do with most of my projects because I like them. And then you can see, like, we define this database adapter, and it has some methods like get all, get by ID, add, update, delete. And you can see the return type is going to be a stream of a list of items, a stream of a single item, a feature of an item, and then 2 features for void. And then also just a quick mention of the generics here. Anything that is mappable means I can convert it to a map or from a map will fit for T. And then you can also see here that we can add T and we can update T. All right, so we can set our adapter collection. This is just a little bit of code to kind of set those adapters up in the actual consuming repos. And we'll see how that's used here in just a moment. But you can see here we take in a collection name, we set an object, adapters, and we set it equal to 2 different adapters, a Hive adapter for that collection name and a Firebase adapter for that collection name. Since then, there's also been like a shared preferences adapter for a couple of these, but it's not used as much. So we can actually look at a repository. So we have a weight repo. This tracks pet weight. You can see that it extends the adaptable repo. It uses a weight log item, which extends mappable. We have our collection name up here called weight. Some other properties that get defined. Our weight repo. It takes into context. You can see that it pulls some stuff out of dependency injection. And then it calls that set adapter collection with the collection name. Now that we've done this and we're using adapters, the implementation for this is actually insanely simple. You'll notice all of these just call the relevant method on the ID. So if we want a stream of weight log items, we say, hey, get the current adapter and then get by ID. If we want to add one, we say, hey, get the current adapter and then add the item, and so on and so forth. And all of the repos look like this now, which is great. You could make the case that, well, maybe all of the repos look like this, we should abstract this out to some other layer. And if you really want to abstract to that layer, you can. This felt like the right layer for me, so that's where we landed. Also, I did mention that we would talk about named parameters a little bit. We have not talked about them much yet. I've actually missed a couple opportunities to do that. A named parameter looks like this. So it's the value that you want to assign it to, the property you want to assign it to, the colon, and then the value. And remember, named parameters are defined like this. So if we wanted to assign the context, it would be context, colon, and then you would pass in whatever you want for the context. So one thing I really like about this is that adaptive apps tend to lead to more choice. For example, we support you choosing your storage mechanism. It might not make sense on web to have the choice. You might have to use the cloud. But if you're on a device that has persistent storage, if I have the code for it already written, why don't I let you choose? So maybe whether you're on mobile or desktop, or you could make a case for web too, if you really wanted to use local storage or something similar, let people choose, especially if your app already supports it. And with Flutter, if it supports it in one facet or one platform, it very likely supports it in the other, unless you're using specific underlying native libraries. Okay, so that makes sense. How do I make the interface actually feel appropriate for the platform, though? Interface expectations can be so vastly different. So you have options. So Flutter gives you access to both of these styles of dialogues. This is the Cupertino dialog. This is the material dialog. What's interesting is Flutter won't say, okay, I look like I'm on an iOS device, so render it like this. And there are some reasons why. Maybe you specifically want to have your entire app look material. I do, but that's a choice. On the flip side, you can actually see that these are, although fairly similar, they're still different in a lot of ways. Not so much rendering, but the context the content that they provide. So there's a header, there's some text, but the material dialogues indicate how actions should be handled for one or more actions. The way that actions are handled here can be quite a bit different. So it gives you the option to choose between the two. Like I just said, Flutter gives you access to both styles and allows you to choose how you want to represent them. So if you want material, you can. What's really interesting is if you have a material app and you want to pull in Cupertino dialogues, I think you can do that too. I don't know why you would. It would feel kind of weird, but I think you have the option. However, I did just say that Flutter doesn't adapt those by default based off the platform, but it does adapt some of them by default. Excuse me. The ones that it adapts are listed in the docs here, but a couple of them that I think are important. Your navigation animations. So does it slide up from the bottom? Does it slide out from the side? Does it fizzle in? All of those, whatever the platform does by default is the one that it supports for that platform. So by default, your navigation will feel adaptive to iOS and Android and so on and so forth. How a user can go back to a previous view. Both iOS and Android support back arrows. What you might not know is iOS supports swiping from the very left side of the screen to the right to go back. And technically, you can go forward by swiping from the right, or you can go, I guess it's not go forward, it's technically go back to go back. But you could swipe the other way to go to the previous screen that you just went back from. Scroll physics is another one. If you fling a list, I'm using the term fling, that's fairly common in mobile development, but literally fling, like you take your finger and throw it across the screen. What happens when it hits the bottom? iOS has a very different behavior than Android, and Flutter supports that for you out of the box. Topography as well. It'll try to use whatever topography makes sense for the platform you're on. Like, for example, Material, I think, is Roboto by default. I don't remember what Cupertino is, or iOS is, sorry. And then your iconography and several more things. And just to reiterate, you can find them all in the docs up here. So this is a really interesting example. I like this one a lot. These are two very different app bars, but they are app bars. The left one is on a calendar. The right one is literally from the Material docs. What I think is really interesting is that there's a lot of similarities. So there's a back arrow here. In theory, if we were a page deeper, there'd be a back arrow here. If we were up a level, there's probably a drawer here. There's a drawer here. There's a search. There's a search. There's actions to do something with a specific view. So for example, you might add a new one. There might be add a new one over here. You might be able to favorite one here. This is pretty neat, pretty common, and they're fairly straightforward. So you could actually implement like an app bar that is open to either of these implementations, really. What I think is really interesting is Flutter, although it started for mobile, has grown a lot, and we've expanded to web. So one thing that I like to think about when I'm building like an adaptive implementation is this app bar enough? So this is kind of funny to think about, but you can see that there's some similarities between our app bar and the browser bar. For example, we have the ability to go back. In a way, we have the ability to favorite an item. Sure, it's contextual to your browser. It's not stored on our cloud server anywhere. We don't have any analytics data about what a user's favorited. Do you need it? I don't know. It kind of depends on what your app does. And then you can make the case that you could search through a search bar. In theory, that's what it's intended for. It's very unlikely going to search your application, although it'd be a lot cooler if browsers could implement that. But yeah, something to think about is like, do I really need an app bar if I'm on the web? Is that adapting? And then if so, do I really need all of this stuff in my app bar if I'm on the web? You probably, for example, it would look really weird if you had a back arrow, but you also had the browser back arrow. Maybe you don't need that if you do show an app bar on the web. So I really like this quote, very, very insightful. Phones, tablets, computers, they usually serve different purposes for different individuals. Feel free to quote that. All right, so some more adaptive patterns beyond the layout. Keyboard shortcuts. Your phone probably doesn't have a physical keyboard. Your tablet might. Your computer almost certainly does. If I'm on a computer, I love to use keyboard shortcuts. I use them all the time. Provide them for me, please. Swipe actions. Conversely, I don't swipe hardly ever with a mouse because it feels really not like natural. But I swipe all the time on my phone. What's really interesting is if you hide things behind a swipe, people probably won't know to swipe with a mouse. Swiping with a mouse is literally clicking and then dragging to left or right in most cases. I would not know to do that. Like if, for example, Gmail uses swipe to show archive on mobile. If I had to swipe through the Gmail web interface to archive things, I would have no idea how to archive them. On the flip side, a lot of the swipe actions exist because there's not enough space to show all those things. If you're on the web, you're probably on a pretty large screen, so you might as well show them. But you can also use media queries and things like that to check. Maybe you are on the web on a mobile device. Maybe you need some other alternative. Scroll bars are so interesting to me. The way that they're handled through platforms is so drastically different. Like if you think about, if you're a web developer and you think about Firefox versus Safari, and those are pretty different scroll bars. What about Firefox and Safari on Mac? Okay, even more different scroll bars. On Linux, probably very different. Let's throw Chrome and IE in there. Maybe Opera. Oh my gosh. Okay, things are getting weird. Also, technically, your list views are scrollable. And depending on the application, I haven't used Android in many years, except for some debugging, so I could be wrong on this. But for a while there, Android had scroll bars. There were virtual scroll bars that showed up whenever a list was very long, and you would start to fling through it to give you some progress indicator on how far you have scrolled. Additionally, you have integrations with existing APIs that you should think about, like how do I integrate with local storage? Location APIs are a big one. Thankfully, web supports them now, but maybe if you're building a desktop client, you might not have access to location APIs. You probably have access to local storage through storing things on the hard drive, but maybe not location. What about screen capture? How do I make sure that not only do I support screen capture, but I support all of the required permissions needed to capture the screen if my application chooses to do that. For example, on iOS and Android, you have to request permissions. Did you know on Mac, your application has to be allowed to screen capture? Windows, I think that it's far more free, but I'm not sure. And then microphone and camera usage as well. Thinking about, well, if I'm on a desktop, can I actually call out to a webcam? Because I might not have a built-in microphone and camera, where most native mobile clients do. So you can kind of, for the most part, assume that they're there and request permission to use them. But you might be requesting permission for nothing on desktop. So Flutter gives you the tools to handle these interactions, but you have to choose to use them. That being said, there are a lot of third-party packages that provide abstractions over these items. So if you are nervous about location services or local storage or whatever, there are so many third-party packages you can use that help with these. So I guess to kind of sum things up, think about the platforms that you're building for. Use other apps on those platforms. What do they do well? What do they do poorly? What's common between apps on the same platform? What's intuitive given the platform that you're developing for? There are tens of thousands of apps out there that don't feel right. Personal opinion, but I imagine most people agree with me. Adaptive apps could be your competitive advantage. Any questions? And I guess, sorry, before we dive into those questions, here's a link. This is the last slide. So if you want more information about me or the app that I mentioned, here it is. So Luna Journal app is the app that we've walked through a little bit. It's a real app. It tracks my pet's epilepsy and other things. So feel free to use it. I blog and teach at bradcypert.com. Also some YouTube videos. You can find me at Brad Cypert. I've started that recently. Twitter if you want to connect, GitHub if you want to connect. And then this talk, here's a link. There's a speaker deck that I'll share out, but this is the actual source for this talk. So if you want the most up-to-date, this is where to find it.